good?
Yeah.
How's everybody doing? Good? Enjoying the conference so far? I know like right about now, this time of day at a conference is usually when I get really sleepy, like 2 o'clock after lunch, just saw a talk, sitting still too long. So if you nod off, that's okay. Just, or if you need to get up and walk out and walk around a little bit, stay awake, I get it. So there's a couple questions I like to start every talk I give with. How many people in the room identify as being a software developer? All right, awesome. So of those of you, how many of you like working on something that you've inherited from somebody else?
Okay. Is his name Stallman or Wormholt?
I wasn't specific on whose it is. So.
It depends on whether I'm told I can just throw it away and start over.
Okay.
Well, can they code? That's
All right. So a lot of caveats about how that work would go. So I, for one, absolutely love working on those kinds of projects. My name is Scott Ford. And picking up where someone else left off is something that I find a lot of fun. So much so that I decided to try to build a company around that idea. And so what we've built is a team of people who absolutely love working on older projects. We like to call this work mending to kind of contrast it with the idea of making. So where a lot of people get really jazzed and excited about like taking something that didn't exist and bringing it into life. We like to take things that already exist and make them even better, or take something that's old and breathe new life into it, or take two things that are old and smash them together to make something new, or take something new and something old and smash those together to make something new. And yeah, we don't build any systems from scratch. We add new features to things. We improve the way things work. That's what gets us excited. So today, I'm going to tell you about a story, tell a story about a time that my team was tasked with building a bridge to a legacy application. And I'm going to talk about the challenges that we encountered along the way, some of the things we tried. And spoiler, it doesn't have the best ending, but I think it's still a story that we learned a lot from, and I think can teach others a fair bit too. So the story starts with me getting a call from a friend of mine, and for the purpose of this story, I'm just going to call him Jeff. His name's not Jeff. And in fact, I'm going to be intentionally vague about a lot of details. I'm going to be vague about the industry that we're working in, and I'm not going to mention the name of Jeff's company. This is, in part because I'm not exactly sure the details of the NDA that I signed and whether or not I can disclose those things. So just be on the safe side. We'll be very, very non-specific. So Jeff's company was building an API across a very fragmented industry. And the idea was to take a landscape where there were tons and tons of vendors that had very inconsistent ways of providing communication with their platforms and providing a very consistent way to communicate across all these vendors. So that anyone who was interested in building an extension on top of these vendor platforms, they could build an integration with Jeff's API, and then that gives them the flexibility to perhaps even switch vendors if they wanted to. So kind of a route to organizations who are like locked into one particular vendor, being able to potentially break that vendor lock-in eventually. We had done some work with Jeff's company in the past. We had helped him build out a test suite to qualify that some of the integrations that he had built were implemented correctly. Tons and tons of vendors that they integrated with. Some of the vendors had different systems that had different capabilities and qualifications that they integrated with. And so there are lots of small little details for these integrations. And so having like one single test suite that they could click and like, okay, this integration is behaving the way the rest of the system will expect it does, was really valuable to him. So he knew from working with me in the past, and he knew from working with us on that project that we really loved the challenge, and he was convinced that he had one for us. So before we get into some more details, a little more background on how his integrations typically worked. So his API would talk to what his team called a connector. And one of these connector services would usually run on the same system where the vendor's system is installed. Some of these vendor systems would be, Linux boxes or Unix boxes. Some of them would be like Windows desktops sometimes, or Windows servers. A very, very wide variety of technologies that they were needing to talk with. So this connector would, communicate in a known protocol and kind of build the bridge between the API and then the vendor's SDK. And most vendors had some form of SDK. And the vendors that they were looking to integrate with were usually pretty happy to provide that SDK because Jeff's company's API was providing capabilities to their customers that they had been wanting to provide. And so they kind of saw this as a benefit to both companies. The vendors' customers were getting extra capabilities at their locations, and Jeff's companies was getting a little bit of revenue. And an API was being built for the vendor's platform without them really having to do anything. So most companies were pretty excited about it. But then Jeff encountered a really, really big client who was using a vendor that he hadn't integrated with before. And this vendor was really reluctant to share any details about the inner workings of their platform. They claimed there was no SDK. They claimed there was no way to integrate with it. They claimed that they were building their own API and were trying to, stonewall the client and say that they shouldn't reach out to Jeff's company and work with them. So this potential client that was courting Jeff's company wanted to see a proof of concept from both organizations. So they told the vendor, you build a proof of concept, and Jeff's company, you build a proof of concept. And so Jeff hired us to try to tackle the problem of some way, somehow, getting the data out of this vendor's system in order to be able to integrate with it. Through Jeff's team's investigations, they discovered some details about the vendor's platform. There were several components to it. There was an on-premises client UI that was in a customer setting facing, so like in a retail location or where somebody would come to the door and work on, provide some kind of input on the system. And then that talked to a centralized service that stored its data somewhere, not entirely sure where. And then there was an admin UI that would allow administrators to set up the look and feel of the client UI, to set up different configuration options, things of that sort. It ran on a Windows 7 desktop, which I thought was an interesting choice, but it was evidently unable to run on newer versions of Windows, which kind of gave us a hint at how old the technology was. And again, there was some details in the documentation that there was a database, but there's no information on who the database vendor was. Was there a database vendor? Was it flat files? What was the storage mechanism? We really had no idea. So we came up with a couple ideas for how we could pretty much attack the system, because they're trying to get at its information that it's hiding below its user interface. So one idea we had is, well, perhaps there's an undocumented SDK that's already installed on the system. The client UI is communicating with the server somehow. Perhaps we can find that mechanism and then take advantage of it and become a client ourselves. Another idea was to try to find libraries that are doing the database communication and go with the data in the database directly. So kind of bypass any normal application communication and just target the database directly. Another idea we had was to actually screen scrape the UI, which I saw some gags in the audience. It was kind of our reaction. And if we needed to, we could certainly try that. So that was one option. The other one was the one that we were really excited about and we really wanted to try, was to reverse engineer the database file format. And this was we were getting really excited about it. People on my team were fighting over who was going to work on the project, because so many of us who really wanted to dig in and tackle this challenge. So we did a little bit of research. We wanted to figure out ways to quickly eliminate options. And so while we're doing our research, we dug in and we took a peek at the screen scraping possibility. And we noticed that there were some severe limitations in the way the UI was built that was going to really cause us some problems. the admin UI was built on top of Win32, so we could have used tools like Win32 API messages to get at all of the details we would need that's on the screen. So we could have remotely controlled the application, gotten values out of text boxes, gotten values out of labels on the screen. It could have worked, but it would likely have been pretty difficult. When we looked in the client UI, what we noticed there is that a lot of the information on the screen was actually drawn there directly. So what we would have had to do instead is somehow capture bitmaps and then OCR the contents, and then that's where we decided that's not going to work. So we scrapped that idea pretty quickly. So that left us with three options, one of which we really wanted to do, and we thought we would be able to do, and we knew it would work if we could actually crack it. But it's also the one way that's probably the hardest. And it would feel really, really stupid and really, really silly if along the way, reverse engineering the database, we discovered that there's an easier way to get at the data. So we decided to attack these problems in order. So first, we decided to hunt for an undocumented SDK, and then hunt for libraries that let us communicate with the database. And then if those two failed, then we would actually dive in and try to reverse engineer the database file format.
So the
Yeah.
vendor, if I heard you right, the vendor told you there wasn't an undocumented SDK, and then they were just thought maybe they were not telling the truth? Is that the idea?
Yeah, they told us there was no SDK, documented or otherwise. So, and so we thought, perhaps it's something, perhaps it's not something that they've documented for external consumption, but perhaps it's something they use internally. And so if we could find breadcrumbs for that it's there, then maybe we could, figure out a way to access it. So that was actually the first thing we tackled is well, maybe there is an SDK hidden somewhere here. So we did a quick hunt for it. We skimmed through the directory structure where the application was installed and just looked at file names and tried to see, is there anything in here that looks like it might be named like what we would expect an SDK to be named. We did find evidence that this is a really, really old application. Granted, this story is only 2 years old. So does anybody recognize that icon?
Oh, yeah. Oh, yeah.
Yeah. So if I remember correctly, that's
Total SDKs and that all over the place.
so if I remember correctly, that's Visual C++ around 3.2 or 3 was that was the default executable icon. Most of the executables in that directory had this icon. So we knew we were working with something that was late 90s, early 2000s in terms of at least when the project was started. So definitely an indication of how old the system was. We used a utility on Windows called dumpbin, which used to come with the Win32 SDK. I think it ships with the Windows Platform SDK if you were to go try to find it now. And what this does is it will take a DLL or an executable, and it will just dump a whole bunch of information, so any function names, any other symbols it happens to find, any strings, type names, things of that sort. There were a lot of DLLs. There's a lot to sift through. It produced really, really long text documents. So probably upwards of 1,000 lines per DLL that we had to kind of skim through, and a lot of it was gibberish because it looked like there was some obfuscation that was going on there that they were taking advantage of. So a lot of the function names that we could see, they were just gibberish. We could tell it was a function. We could tell it took 3 parameters. That's about all we could tell. So not a whole lot of help there. So then our next question was, well, let's go ahead and try to get at this data directly. And maybe we'll get lucky and they're using an off-the-shelf database that we can find external libraries for. So if that was the case, we thought we would find some database access DLLs or some indication of a known file format or something like that. So we looked for evidence of a commercially available database. If you name it, we looked DBase, FoxPro, Access, Postgres, MySQL, SQLite. Everything we could think of, we did a really exhaustive search for any evidence of any of those file formats, and we saw nothing. So then we went back through the dumpbin output, and we looked again, this time not looking for not looking for functions that would tell us give us some indication of like how to get particular data elements that we were looking to get, but instead like, maybe functions that would let us read from a table or execute a SQL query or, see a data value that's in a column or anything that might be data related. We didn't find anything. We did find a few .NET DLLs that were there. We decompiled them. And they were also obfuscated. They were obfuscated to the point that they crashed the reverse engineering program they were using. And we tried several of those as well, and it crashed most of them. So it was very well obfuscated. This company definitely invested well in trying to make sure that people couldn't do what we were trying to do. So nothing obvious found, so we got really excited. Because we got to do what we really hoped we'd be able to do, which was like, crack open some binary files and start reverse engineering the data that's inside them. But first we had to find those files. So this isn't the tactic that we chose for this was to open up the admin user interface, made some edits, closed the admin user interface, and then just looked for something in the file system with a date timestamp that was very recent. And we got lucky. We found one file, and I don't remember the exact extension, but it was something really generic, like .bin. And so again, like, that was I was worried there was going to be like thousands of files, but it turned out it was only one, which is good. So then we turned to my favorite hex editor, which is called Senilize. There's it's Mac only, but there is a Windows and Linux version called Hexinator. If you've never worked with it before, it is really neat. One of the things you can do with it is kind of investigate unknown file formats. And as you're investigating them, you can build a grammar that defines this file format. And it's able to generate code for reading that grammar in some languages. I think it can generate C code for you. It can, I think there are plugins that will generate reading code for some other languages as well. But you can map out the structure of the actual raw binary file format. And it has like color highlighting, which is a little hard to see in this picture, but up here, there's like some pink. If the grammar kind of defines the color highlighting, it can be there. This screenshot is one that I took. This is just a random DBase database file that I found on the internet. And DBase is one of the built-in grammars that Senilize has support for. You can open up a JPEG file, and there's a grammar defined for that. And so it's a really handy tool, especially built for our purposes. Another thing we're able to do is we could select any blocks inside of the AirPlay passcode. No, it is not part of the presentation. You have a really good straight face, by the way. That's good. You had me there. How do I switch back to?
You're one of these other ones.
Okay.
I think it was 8.2.
Yeah, I think so. That's definitely not the one that says Apple TV, right?
So whoever was trying
Process
to
of
stream
elimination.
earlier, you're disappointed. Okay,
Why
we're
did
back.
it change?
Don't know. Maybe I stood still for too long. Thank you. Another thing that's really nice about Senilize is you can highlight a block of data, and you can tell it to attempt to parse that data in tons of different formats. You could say like, interpret this as a float for me, interpret this as an integer for me, interpret this as a UTF-8 string or a UCS2 string. And there's lots of different ways that you can look at different pieces of data and try to get a sense of what it is. And then it also has good support for different byte and word ordering. So you can see like big Indian versus little Indian for byte ordering. So definitely a really good, well thought out tool for reverse engineering a file format.
And on Mac it was called
Hexinator.
Hexinator.
It's built by the same company, both tools. And Hexinator is billed as like a freemium version of Senilize. So the Mac users get to pay for it, but the Windows and Linux people get it for free. So we have the database open in a hex editor. We hunted around for strings. We found a list of what looked like table names. We found that one of the tables was named B-tree. Anybody here with a computer science background?
Yep.
Okay. So B-tree is a way to build a binary search tree based index with that levels itself. It's what most modern databases use to build out an index. So that told me that not only are we looking at a custom database, but we're looking at a team that built their own index for a custom database engine. So, and it was likely built, this database system was likely built sometime in the 90s, and between then and 2017, the team never once decided to actually replace it with something off the shelf and more modern. So it was definitely fascinating from that perspective, almost like an archaeological perspective. So while we're looking at the data in Synalyze it, we're also looking for patterns. So when we found the areas with the database table names, we found that the next 6 bytes were blank, had some numbers in it until we got to the next column name. And when we looked at those bytes, we discovered that some of them were offsets to other locations in the file where we'd find other information about that table. So one particular value was an offset to where we would find column names. And next to each column was some metadata about the type that column contained and how many bytes wide it was. So if it was like a string or a varchar, how much space it was going to take up. And then also back in the table metadata, there was another location that we discovered was also a location of the file, but that's where the actual raw data started. So by combining the metadata about the table, the columns, the data types, we're able to actually start to piece together what data is stored here. Are these integers? Are these floats? And then to validate our assumptions, we kind of ground through, and for every piece of information that we wanted to get out, we went to the UI, we made a change, and then we did a before and after diff. And Synalyze it has a diff feature where you can get a before and after view. So we were able to save a copy of the database, make our change, do a before and after diff, and validate, yes, those 4 bytes really are an int. Yes, they did change from 15 to 16. We're good. And we could do other tests to validate that the byte ordering was what we expected by picking values that are big enough to actually make the byte ordering matter. So these were lots of assumptions we had to validate. And we marked all of our assumptions, Synalyze it, and we repeated over and over and over and over again for every field that we needed to get out. And this took weeks. This was the big bulk of our investigative effort. But we really felt like we were making progress. And to simplify things, we really only focused on the data we needed. We could have tried to map out this entire binary file and produce this really awesome documentation for everything that was in there. But at the end of the day, we didn't really know if everything in there was being used by the application. There's a good chance that given how old this application was, that a lot of the information in this database file just is dead, right? It perhaps will always be 0. Or even if we did find a column, perhaps it's never updated, things of that sort. Things I see all the time in more modern applications with more modern databases, you'll have people leave tables and columns around just because it's easier to do that than it is to delete them. So had to assume that something similar was taking place on this application. So our next task was actually, now that we know a lot about the database, we've collected enough information through reverse engineering, changing field values, finding out where things are, we now have enough information that we needed to actually start building out a connector. And one of the things we were instructed to do for this demo was it only needed to be read-only. So we didn't have to worry about writing back to the database at the same time that the system is trying to write to it. We did start to come up with some back-of-the-napkin ideas for how to go about doing that, like moving the file off to another location, making our writes to it there, looking to see if it had changed, swapping it back really quickly. All risky stuff. trying to kill it, trying to put an OS level lock on the file so that we were the only ones who had write access to it. A lot of different ideas that we had played around with for trying to make sure that we wouldn't corrupt the data if we did try to write to it, because that was definitely a concern that we had. So what we ended up with is now we have a connector, and we've basically built our own custom SDK. And so now we're ready to go demo to the client. And the demo kind of went something like this. I wasn't at the demo, so what I'm hearing is all kind of secondhand. But the way it was told to me is that the CTO of the vendor was present at the demo. And they were really alarmed that we were successful. Because it turns out there was an SDK. And when they found out that we had plans for read-write support, they decided to hand it over. So, and
They never threatened any legal action?
no.
Okay.
So my team was like, man, because we're really excited about this. Like, we were having a lot of fun. We were looking forward to the rewrite version. And so it was like, there was a lot of, initially there was a lot of disappointment. And so I tried to spin things around and say, okay, not so fast. We learned a lot through this process. One, we thought we could do something like this, but now we know we can do something like this. It was a lot of fun. Like, I hopefully how much fun I had is being conveyed. I know a lot of you are like cringing at the thought of some of what we put ourselves through, but we really enjoyed it. Like, we really enjoyed this kind of work. And one thing that I think is a really good positive is, like, because we did what we did, it ended up with the best solution for everybody, right? Like, the safest way to integrate with this system is through an SDK that's approved by the vendor. Like, that's the absolute safest way to go about doing it. So the fact that, like, even if it was like, perhaps some like really ugly business-to-business politics taking place, or maybe even interdepartmental politics at the vendor level, who knows? But for some reason, the CTO was like withholding an SDK and then provided one. And that's because like the read-write implementation would have been incredibly risky for us to implement. We would have tried it. We would have found lots of bugs. We would have done our best to make them work, but it would have been expensive for Jeff's company. It would have started to get in the realm of frustration and discouraging for us. And it likely would have drawn the attention of the vendor in a very negative way, because we would have been corrupting their data. Just say, like, the probability was incredibly high that we would actually corrupt data once we tried to do the read-write implementation. So, as I almost always do, no matter how hard I try when I give a talk, I breeze through my material very quickly. But I do love facilitating discussion. So if any of you have any questions, I'd love to hear them. Yeah.
What was the size of Jeff's company?
So Jeff's company was, I think, about like 15 to 20 engineers. Most of them were focused on building and maintaining the API proper, with a few people who were focused on kind of owning each individual vendor integration. So they'd have like small 2, maybe 3-person teams kind of focused on a particular vendor, but the bulk of the team was focused on kind of making the API platform work, selling access to the platform, things of that sort.
So were they serving somebody else, or was this their own company? Like they're doing it for United Airlines or something?
Exactly. So Jeff's company has customers, right? And their customers have this vendor software installed at their location, right? And they're looking for a capability out of it that they're not able to get. And so that's where Jeff's company comes in and says, hey, we can do this for you. You want to build out, some cool feature that involves cell phones, and your vendor system was built before cell phones were in existence, or the idea of a smartphone was even thought of. And so, like, hey, we can be a shim and provide you that capability. So that was kind of the sales pitch. Yeah.
Why again wouldn't they give you the SDK?
I don't know. I wish I knew why they wouldn't give us the SDK. I can conjecture that, maybe it was a case where the marketing department at this vendor, or the marketing and sales department at the vendor, was really excited about them being able to gain this new capability without having to without necessarily having to spend any money to get it. But then maybe in the IT organization felt threatened by that, right? So like, but again, that's just a speculation. I don't know. I've seen similar things play out at other companies where one department kind of feels under threat by an outside organization. And when your livelihood is threatened, you sometimes make some odd decisions. But yeah, I think yeah, not sure. Yeah, not sure. Yeah.
So did y'all change your practices after that, going, now here's how we should have found the SDK?
Yeah, like looking back, I'm not sure what we could have done differently to find the SDK.
But now that you know, then it'd be like, oh, we looked for this.
Yeah.
And now we just have to present and tell them, hey, they handed it over to us.
Yeah, it's like yeah, we could certainly say like we've done this once before. Like if your IT organization is withholding something, we'll get at the information. Like we can get at it. So yeah, I don't know.
You said you focused it only on what, operations and like the GUI that you needed, right?
Mhm.
Proportionally, how many calls compared to like legacy, stuff was that? Like, was it like 10% of the code was used or?
You mean it's like 10% of the database
Yeah.
table columns, things like? Yeah, it was probably around 20% that we ended up actually using. A lot of what was in the database was configuration information for like the way the client UI was displayed and things of that sort, or like different minimum and maximum values for just like enforce different business rules. So those were all details that like were definitely important to the vendor, but for our integration they weren't as big of an issue.
Why were they so married to this product that was such an old fossil? Wouldn't they have looked at it as a business risk, saying,
Yes.
this weirdo undocumented thing our business is based on, we need to migrate. Y'all tell us how to migrate.
Yeah, so the landscape for these vendors, and it's like, and this is the reason why I'm not being very non-specific about the industry, but in this specific industry, there are, it's an application, it's a hardware and software that's installed at a physical location, and it's often for large chains that have thousands or sometimes hundreds of thousands of locations. So switching vendors is incredibly costly,
Okay.
and the vendors know that.
Like point of sale on all the targets, you gotta swap all your registers, that's a lot.
Yeah, exactly. Yeah. So something, if it was like a coffee shop, right? Like the switching cost for them is a lot less than say like on the scale of like a Walmart or something like that.
Yeah.
So yeah. Mm-hmm.
I've just got a quick one. So sorry, it'll probably be a bit dumb because I'm not a software engineer, but I do a bit of research in Australia around infrastructure protection. So we're looking at things like, protecting SCADA or industrial control systems or something like that, where some of them are 50 years old or 30 years old. So to try and mitigate that IoT convergence risk, is there some generic stuff that you think, if there wasn't a specific SDK or particular solution for the myriad of really old stuff that's around, is there some generic lessons that you learned in how we would actually make these shifts?
I think one of the lessons is that it's going to be a lot of work, and it's often worth it. So like I think even if we had only had to stop at read only, that would have been a read only capability that didn't exist for that system. So I think it's one of those things where if the system is still providing value, and if it's been around for 15 years, it's still providing value. Nobody's decided to turn it off. So it's more of one of those things of like, I think instead of trying to just outright replace it, embrace it, figure out a way to kind of modernize it at the edges.
I think it's the reality of the
Yeah.
IoT is going to come before most of this stuff.
Right. Yeah. So I think the proliferation of lots of small devices is going to mean that some of these older systems with
Or just connecting on top of networks.
yeah exactly. So, any other questions or discussion points? Yeah.
I got a question. At the very beginning of your slides, you had a keyboard. What type of keyboard was that?
QWERTY.
It was not QWERTY.
It wasn't Dvorak. Yeah.
Oh, you mean on the
The
typewriter?
keyboard in the first slide.
Typewriter, yeah.
Top row spelled out
Top row.
Caesar. It's like, what the ding dong kind of format is that?
Typewriters before scanner.
I love this audience because I didn't notice that.
See?
Yeah.
It's not Dvorak.
No,
What is it?
I typed Dvorak, and that's not Dvorak.
I see a fancy C on the bottom.
I see a English
Yeah, it's
pound
like-
sign on the top.
Yeah, I don't know. That's a
Weirdo Brit.
I leave that as an exercise for the audience. Maybe this is a different typewriting vendor who really likes Caesar, or maybe Caesar is the name of the typewriter, or who knows?
Where's numeral 1?
Yeah.
Old typewriters use lowercase l. That's true. Now we know how old I am. You can post this as a tweet saying, hey.
Yeah. We'll post this and see if anybody on the internet knows the origins of this layout.
Let's see, what's under, is there a
It's
thing
called
on the
H.
C?
Caesar.
Huh?
It's called H. Caesar.
Oh, somebody's already found a layout. It's the layout is H. Caesar.
Pronounced by saying the name of the letter H and then the word Caesar.
Like the top row with the P.
Like the tarp. Yeah.
It's Portuguese.
Portuguese. Okay, there you go.
C, the, under
Right
the
here?
C on the bottom.
Yeah, it's got a little
That's a giveaway.
H.
And the
Caesar,
weirdo
that's
A.
how they say it.
H. Caesar. Okay, well, there you go.
Decreed 1937 by the Portuguese dictator.
Okay.
Wow.
See, this is an awesome audience. If I give this talk again, I'm leaving it in there, and if people don't notice, I'm gonna call them out on that.
First
So-
engineer this.
Yes, right.
Cool.
So, if if what? Did you have?
I said fun.
Oh. So if stories of this sort fascinate you at all, I encourage you to check out. We have a community that we manage called LegacyCode.rocks. We have a podcast of the same name, Legacy Code Rocks. We've actually the other engineer on my team who worked on this project with me. We interviewed her on one of our early episodes. So if you want to hear how excited and happy she was to work on it, I think she went through like 90% of the grind or 100% of the grind. So she's the one who really deserves all the credit for this.
What's the legacy code .rocks? I don't recognize .rocks.
So .rocks is a top level domain.
Really?
Yeah.
There's thousands of them.
Yeah. So, but yeah, so if you go there, we have a Slack team that you can join and chat with other people who enjoy working on legacy code. I guess people here could go heckle them. I don't know. I didn't see a lot of takers. We also have a weekly mastermind where we talk and commiserate about working with older systems. So yeah, I appreciate everybody's time and thanks for the great questions and noticing the keyboard layout. That's awesome. Thank you.